everyone, welcome to my channel. Today I am going to start 4th module in Engineering Mathematics 1, especially for Computer Science Engineering students with subject code 22MEATS11. Subject name is Modular Arithmetic. Before going to the topic directly, first let us understand some of the basic topics in modular arithmetic. First topic is divisibility. Let us understand what is divisibility. Let a and b be two integers and a not equal to 0. We say that a divides b if there exists any integer k such that b is equal to a into k. Here this is a definition of divisibility. Here we are saying a divides b where a and b are integers. Here modular arithmetic is fully based on the concept of integer. So we have to take any two integers a and b with the condition a not equal to 0. We say that a divides b. Here this condition holds if there exists any integer k such that b is equal to a into k. Here a divides b holds if and only if we can write a divides b in the form of b is equal to a into k, where k is some integer. So this is a definition of divisibility. Here if a divides b, we can write in a symbol as this. It is a divides b. This is a symbol of a divides b. Here a divides b is same as that of b divided by a. Here a divides b is same as that of b divided by a. Both are same. Here a divides b, we can write it as b divided by a. Both are same. If a does not divides b, we can write in a symbol as this. That is a does not divides b. Let us take some example. Here 13 divides 39. We can say 13 divides 39 because we can write in the form of b is equal to a into k. Here 13 divides 39, we can write it as 39 which is equal to 13 into 3. Here 3 is an integer. So we can write 39 in the form of 13 into some integer. So we can take 13 divides 39. Here 13 divides 39 is as same as that of 39 divided by 30. Take another example. 12 divides 84. Here we can say 12 divides 84. This is because 84 we can write it as 12 into some integer 7. That is 12 into 7 is 84. So we can consider 12 divides 84. Here 12 divides 84, we can write it as 84 divided by 12. In the similar way, we can take 7 does not divide 24. This is because we cannot write 24 as 7 into some integer. That means if a divides b means we can take it as b is equal to a into k. Here 7 does not divide 24 because we can't write 24 as 7 into some integer. So 24 is not equal to 7 into some integer. So this is about divisibility. Here we can say divisibility condition holds, that is a divides b. That means we have to satisfy the condition b is equal to a into k, where k is some integer. A divides b, we can write it as b divided by a. Both are same. Next we shall see some of the properties of divisibility. First property is a divides a for all a belongs to z. Z is an integer and a not equal to 0. Here if these two condition holds, we can take a divides a. This is because we can take some example, that is 2 divides 2, because we can take 2 as 2 is equal to 2 into 1. So we can write 2 divides 2 in the form of b is equal to a into k. So we can take it as a divides a condition holds for all a belongs to some integer z, and main condition is a does not equal to 0. A must not be equal to 0. Here take the condition 13 divides 39. I am saying 13 divides 39 same as that of 39 is divided by 13. Here if we take a value is 0, this value becomes anything divided by 0 is infinity. So this value becomes infinity. So we have to take the condition as a does not equal to 0. This is a very important condition to say a divides b. So the property says a divides a for all a belongs to z and a not equal to 0. Similarly a divides 0. Here a divides 0 is same as that of 0 divided by a. So that value becomes 0 itself. So a divides 0 condition holds, but not 0 divides a. Here second property is a divides 0 for all a belongs to z and a not equal to 0. Third property is 1 divides a for all a belongs to z. Here 1 divides a, if we substitute in the place of a as 2 means we can write in the form of 2 is equal to 1 into, here some integer we can take it as 2 itself, so we can write in the form of b is equal to a into k. So this condition holds, that is 1 divides a. Similarly, minus a divides a for all a belongs to z. Here if we take a negative sign also, the condition holds, that is minus a divides a. Next property is, if a divides b, which implies a divides b into x for all x belongs to z. Here this is a multiplication property. Here a divides b, which implies a divides b into x for all x belongs to z. If you multiply in the place of b with x, it satisfies the condition a divides bx for all x belongs to z, that is x must be an integer only. Next property is a divides b and a divides c, which implies a divides b plus c. Here if we take 1 divides 2 and 1 divides 3, we can take it as 1 divides 2 plus 3. 2 plus 3 is 5. So the condition is 1 divides 5. We can write 5 as 1 into 5. So a divides b and a divides c implies a divides b plus c also holds. Another property is a divides b and a divides c implies a divides b into c. Here if a divides b and a divides c, then we can take a divides this multiplication value also, that is a divides b into c. Also we have a divides b and b divides c implies a divides c. Here if a divides b and this b divides some value c, then we can conclude a divides c. These are all some of the properties on divisibility. We shall move on to another topic, that is division algorithm. Let a comma b are two integers, a not equal to 0. There exist integers q and r such that a is equal to bq plus r is greater than or equal to 0 and r is less than modulus of a, where a is dividend, b is divisor, q is quotient and r is remainder. Here division algorithm we can write it as dividend, which is equal to divisor into quotient plus remainder. So this is a division algorithm. This method is used to find whether the division method performed is correct or not. This is a division algorithm. Let a and b are any two integers and a not equal to 0. There exists another integers, that is q and r, such that a is equal to bq plus r. This algorithm is nothing but a division algorithm, where a is nothing but a dividend, b we can call this as divisor, q as quotient and r is remainder. This is about division algorithm. Next we shall study about greatest common divisor. Let a and b are two integers. An integer g greater than 0 is said to be GCD of a and b if, here we have to consider two integers a and b. Also we have to consider another integer g which is greater than 0. This g is said to be GCD, that is greatest common divisor of a and b if the following condition holds. Here first condition is g divides a and g divides b. Here we are telling g as a GCD of a and b, that means g is a common divisor of a and b, that g must divide a and b. Next condition is, if there exists any common divisor of a and b, that is if h divides a and h divides b, implies h must divides the value, that is the greatest common divisor value g. If these two conditions satisfies, we can call g as a GCD of a and b. Here they will give two integers a and b. We have to find the GCD of, we have to consider GCD of a and b. That means that g holds these two conditions, that is if g divides a and g divides b. Also there exists any common divisor of a and b, that is h divides b and h divides a, which implies h must divide the GCD value g. If these two conditions holds, we can call that value g as a greatest common divisor of a and b. Here GCD of a and b is denoted by the symbol open interval of a comma b. Here in the arithmetic, open interval a comma b is nothing but a GCD of a and b. Next we shall study Euclid algorithm. Here Euclid algorithm is a method to find GCD of two integers a and b by successive division. The last non-zero remainder will be the GCD. If g is equal to a comma b, then by using division algorithm successfully, we can find integers x comma y such that g is equal to ax plus by. Here the method Euclid's algorithm is a method to find the GCD of two integers a comma b. Here we can easily find the GCD of two integers a comma b by the method called Euclid algorithm. We are finding the GCD of two integers by Euclid algorithm means we have to first find the division for the any two integer. Then the last non-zero remainder will be the GCD of two integers a and b. We can write it in the form of g is equal to a comma b. Then by using division algorithm, here the division algorithm is nothing nothing but a is equal to bq plus r. By using this procedure, we can find the integer value x and y such that we can write in the form of g is equal to ax plus by. Let's see how to find Euclid algorithm in coming problems. Next, we shall see what are all the applications of modular arithmetic in computer science engineering. Modular arithmetic has wide range of applications in computer science engineering. In cryptography, modular arithmetic is fundamental in cryptographic algorithms like RSA and Diffie-Hellman key exchange. In these algorithms, modular arithmetic operations such as modular exponentiation and modular inverses are employed to encrypt and decrypt data securely. In hash functions, cryptographic hash functions such as SHA-256 often utilize modular arithmetic operations to manipulate large numbers efficiently. Modular arithmetic helps ensure that the hash values are within a certain range and exhibit disseparable properties. In error detection and correction, modular arithmetic is used in error detection and correction techniques like checksums and CRC. These techniques involve performing arithmetic operations on blocks of data and using modular arithmetic to ensure integrity and detect errors. In computer graphics, modular arithmetic is employed in tasks like color manipulation and texture mapping. For instance, in RGB color representation, modular arithmetic ensures that color values remains within the valid range. Modular arithmetic is utilized in various data structures and algorithms. For example, in hash tables, modular arithmetic is often used to map keys to array indices efficiently. Also in algorithms like prims and Kruskals for minimum spanning tree construction, modular arithmetic helps manage and compare edge weights effectively. In random number generation, modular arithmetic plays a role in generating pseudo-random numbers. Many random number generators use modular operations to ensure that the generated numbers fall within a desired range and exhibit statistical properties necessary for applications like simulation and cryptography. In network protocols, modular arithmetic is utilized in various network protocols for tasks such as packet sequencing and error checking. For example, in TCP or IP, modular arithmetic ensures reliable data transmission and error detection through sequence number and checksums. So these are all some of the applications of modular arithmetic in computer science engineering. So we are necessary to study modular arithmetic in engineering field. Next, we shall solve some problems on finding greatest common divisor. Here is the first problem. Find the GCD of 54 and 7 and express it in the form of 54x plus 7y. Here first take the given data. Here they are asked to find the GCD of 54 and 7. Here to find the GCD of 54 and 7, that means finding the GCD of any two integer means we have to use Euclidean algorithm here. Here finding GCD with the help of Euclidean algorithm means you have to find the division method. We have to use division method for 54 and 7. Here in 54 and 7, the smaller value we can call this as divisor and the greater value, that is 54, is dividend. So we have to use a simple multiplication table here. Here we can take in the place of quotient as, here we know that 7 into 7 is 49. So we can take in the quotient place as 7. If we take in the place of quotient as 8, 7 into 8 we get a value as 56, that is greater than 54. So we have to take here as 7. Hence we get 7 into 7 as 49. We have to minus this 54 and 49 value. We get a value as 5. So we can call this as a remainder. So this is a division method. Here 7 is a divisor, 54 is dividend, and this value 7 is a quotient, and the final value is a remainder. We already know that this is a division method value. So next we have to divide this divisor value with the help of remainder. That is 7 divided by 5. So we know that 5 into 1 in the place of quotient we get a value as 1. So we get 5 into 1 as 5. 7 minus 5 we get a value as 2. So 2 is a remainder for this division method. Next we have to continue this division method till we get a remainder value as 0. Next step, 2 is a remainder. So we have to divide this divisor value 5 with the help of 2. So take like this. We have to divide this 5 by 2. So we can take the quotient value as 2. we know that 2 into 2 we get a value as 4. If we take in the place of 2 also as 3, 2 into 3 that becomes 6, that is greater than 5. That is not possible. So take a value of quotient as 2. So we get 2 into 2 as 4. Next, subtracting this 5 and 4 we get a value as 1. Next, take this divisor value here. So divide divisor value 2 by 1. Next, we have to get the value as 2. You know that 1 into 2 is 2. Therefore, we can take in the quotient value as 2. So we get 1 into 2 as 2. Therefore, we get 2 minus 2 value as 0. Finally, we get a remainder value as 0. We have to stop. So we have to stop the procedure over here. If we get a remainder value as 0, then the procedure ends. Therefore, once we get a remainder value as 0, we can stop this method. Then by the method of Euclidean algorithm, it says the GCD of the value A and B is nothing but the last non-zero remainder. We already discussed what is a Euclidean algorithm says. That is, the last non-zero remainder in a successive division is nothing but a GCD of the two integers. So we can conclude that the GCD of 54 and 7 as 1. Therefore, GCD is equal to 1. This is because the last non-zero remainder. Here, the division method ends if we get a value of remainder as 0. The last non-zero remainder. Here, 5 is also in remainder, 2 is also in remainder, 1 is also in remainder, and 0 is also in remainder. But the last non-zero remainder here, previous to this 0 value is 1. So we can conclude the GCD of this value, that is 54 and 7 as 1. Also, we have to check here GCD is 1. That means we can take it as this 1 divides 7 and also this 1 divides 54. So we can conclude GCD value is 1. Therefore, we can write it as GCD of 54 and 7 value as 1. First step is completed, that is find the GCD of 54 and 7. This value is completed. We know that GCD of 54 and 7 value is 1. Also, we have to express this 54 and 7 in the form of 54x plus 7y. So to continue this procedure, we have to continue this Euclidean algorithm procedure. That means with the help of division algorithm, we can write this division algorithm method is nothing but dividend which is equal to divisor into quotient plus remainder. So for this division method, we can take division algorithm method as 54 which is equal to here 54 is a dividend which is equal to 7 is a divisor and 7 is a quotient. So we can take it as dividend which is equal to divisor into quotient plus remainder. So we can take it as 54 which is equal to 7 into 7 plus 5. So we get this value with the help of division algorithm method. We are applying division algorithm method for this first division, or we can take this value as, if we take this value as 5 which is equal to, take this value to the left hand side, we get as 54 minus 7 into 7. Call this as equation number 1. Similarly, for this division, we have to apply division algorithm method. We get a value as, here 7 is a dividend, 5 is a divisor and 1 is a quotient, and here 2 is a remainder. So we can take division algorithm method, that is dividend which is equal to 5 into 1 plus 2. So by our division algorithm method, we can write 7 as 1 into 5 plus 2, or we can take 2 which is equal to, take this value to the left hand side, that becomes 7 minus 1 into 5, and call this as equation number 2. Also, we have to apply division algorithm method for this division value also, that is 5 which is equal to 2 into 2 plus 1. That is, here 5 is a dividend, 2 is a divisor, here 2 is a quotient and 1 is a remainder. So we can take it as 5 is equal to 2 into 2 plus 1, or we can take 1 which is equal to 5 minus 2 into 2. Call this as equation number 3. So this is a procedure to find the greatest common divisor, and we have to express it in a some linear combination method. So by Euclid algorithm method, we are finding GCD and express it in the form of 54x plus 7y. So applying division algorithm method for this division values, we get these three equations. Call this as equation 1, equation 2, equation 3. Next, from equation 3, we have to consider the last equation. That is equation 3, we have 1 is equal to 5 minus 2 into 2. Here from equation 3, we consider this equation 3. We have 1 is equal to 5 minus 2 into 2. Next step, we know that from equation 2, we can write in the place of 2. Here we have 2 into 2. So we can take in the place of 2 as 7 minus 1 into 5. That is 1 is equal to 5 minus, in the place of 2, we can write it as 7 minus 1 into 5 into this 2 as it is. So this is obtained obtained from equation 2. Next step, multiply this 2 inside the bracket. We get as 5 minus this 7 into 2. Here minus to minus plus 5 into 2, which is equal to, or we can take it as, here this is 5 into 1. Here this is 5 into 2. If we add this value, we get as 5 into 3 minus 7 into 2. Here we can take, in these 2 we can take 5 as common. The remaining is 1 plus 2. Therefore we get 1 plus 2 is 3. Therefore we can take it as 1 into 3 minus 7 into 2. Next step, for this equation, we have from equation 1, we can write in the place of 5 as 54 minus 7 into 7. So 5 into 3 minus 7 into 2. For this, apply equation 1. Here in the place of 5, we can substitute as 54 minus 7 into 7. We get as this 54 minus 7 into 7 into 3 as it is minus 7 into 2. Here multiply 3 inside this bracket. We get as 54 into 3 minus 7 into. Here our aim is to express it in the form of 54x plus 7y. So we are finding this 54 into some values and 7 into some values here. Here we multiply 3 inside this bracket. We get as minus 7 into, here 7 into 3 is 21. Minus 7 into 2 as it is. Now we can take in these two value. Here this is minus 7 into 21. Here this is minus 7 into 2. If we take minus 7 as common, we get as minus 7 into 21 plus 2. 21 plus 2 is 23. Therefore we get as 54 into 3 minus 7 into 23. Or we can take it as 54 into 3 plus 7 into, if we take this value inside the bracket, we get as plus 7 into minus 23. That is a value of 1. That is 1 is equal to 54 into 7 plus 7 into minus 23. Or we can take it as 1 is equal to 54x plus 7y, where in the place of x here is this 3 and in the place of y is minus 23. So we are expressing it in the form of 1 is equal to 54x plus 7y. This is because by Euclidean algorithm says g is equal to GCD of a comma b. That implies g, which is equal to, we can express in the form of g is equal to ax plus by. We already studied the Euclidean algorithm method that says we can express in the form of g is equal to ax plus by. Here in the place of a, we can take it as 54 and b as 7, because we are asked to find the GCD of 54 and 7 and express it in the form of 54x plus 7y. So this is a procedure to find the GCD with the help of Euclidean algorithm method. This completes the problem. We shall move on to another problem so that you can understand in a better way. Find the GCD of 385 and 792 and express it in the form of 385x plus 792y. Here they are asked to find the GCD of some two integer, means you have to apply Euclidean algorithm method. Euclidean algorithm method means you have to find the division values, that is successive division for given integer. After finding the successive division for given integer, the last non-zero remainder will be the GCD for this given two integer. And also the Euclidean algorithm says we can express that Euclidean algorithm values in the form of g is equal to ax plus by with the help of division algorithm method. First take the given data. Here we have to find the GCD of 385 and 792. Here applying Euclidean algorithm method means you have to do division method first. For that, here 385 is a divisor and 792 as a dividend, because we have to divide the greater number with a smaller number. So 385 is a divisor and 792 as a dividend. So from the multiplication table, here we can take 385 into 2. You know that 385 into 2 as 770. If we take 3, that is greater than that of 792. So we have to take as 2. Therefore, if you multiply this value, 385 into 2 is 770. Next you have to subtract the 792 with 770, we get a value as 22. This is a remainder. Here this is a first step of division. Here 385 is a divisor, 792 is a dividend, 2 is a quotient and 22 value is a remainder. Next we have to divide this divisor value with the remainder, that is we have to divide 385 with 22. You know that 22 into 17 is 370. Next we have to take the quotient value in the way that we have to multiply this quotient value with the divisor. We get a value equal to dividend value or nearly equal to dividend value. So we are taking this quotient value as 17, hence we get 22 into 17, we get a value as 374. If we subtract 374 with 385, we get a value as 11. We have to do subtraction here. Here 385 minus 374, we get a value as 11. Next we have to divide this divisor value value with this remainder, that is 22 is divided by 11. We know that 11 2s are 22. So we get quotient value as 2. 11 to 2 is 22. We get a remainder value as 0 here. Here 22 minus 22 is 0. We have to stop the division method here, and we can conclude that this value, that is 11, this is a last non-zero remainder. So we can take the GCD value is 11. This is because the last non-zero remainder is 11. Therefore, we can conclude that the GCD of 385 and 792 is 11. Also, we have to note that the last non-zero value, that is GCD value, divides 792 and 385 also. That is 11 divides 792 and 11 also divides 385. So we can conclude the GCD of 385 and 792 as 11. This is a greatest common divisor for all these divisions. So we can conclude this is a GCD for 385 and 792. Once you obtain the GCD value, with the help of division algorithm method, we have to express it in the form of 385x plus 792y. Here, for this first division method, the division algorithm says, here the division algorithm is nothing but dividend, which is equal to divisor into quotient plus remainder. Here dividend is 792, which is equal to divisor is 385 into quotient is 2 plus 22. Or we can take this as 22, which is equal to, take this value to the left hand side, we get as 792 minus 385 into 2. Call this as equation number 1. Similarly, for this value, the division algorithm method is dividend, which is equal to divisor into quotient plus remainder. Or we can take this as 11, which is equal to 385 minus 22 into 17. Call this as equation number 2. Here remainder is 0, so don't take the division algorithm for this value. Stop here itself. Here next step, take this equation number 2. It is from equation 2, we can take it as 11, which is equal to 385 minus 22 into 17. Next, from equation number 1, in the place of 22, we can substitute as 792 minus 385 into 2. That is 11, which is equal to 385 minus, in the place of 22, we have to substitute as 792 minus 385 into 2 into 17. Next step, multiply 17 inside the bracket, we get as 385 minus 792 into 17. Here minus 2 minus plus 385 into, here 2 into 17 is 34. Next, we know that here this is 385 into 1. Here we have 385 into 34. So we can take 385 as common over here. We get as 385 into 1 plus 34 minus 792 into 17 as it is. Therefore, we get 385 into, here 1 plus 34 is 35. If we take this minus inside the bracket, we can take it as plus 792 into minus 17. Therefore, this is of the form 11, which is equal to 385 into 35 plus 792 into minus 17x. Therefore, we can express 11 in the form of 385x plus 792y, where x is 35 and y value is minus 17. Therefore, we can conclude that 11, which is equal to 385x plus 792y, where x is 35 and y value is minus 17. By using division algorithm method, we can express in the form of 385x plus 792y, where x is 3 and y value is minus 17. This completes the problem. We shall move on to another problem. Find the GCD of 32 and 54 and express it in the form of 32x plus 54y. This is very easy problem. You have to solve the GCD of two integer means you have to apply Euclidean algorithm method. Here take 32 as a divisor and 54 as dividend, because you have to divide 54 by 32. Take like this. We are dividing 54 value by 32. You know that 32 into 1 is 32. If we subtract this 54 by 32, we get a value as 22. This is a remainder. 1 is a quotient and 32 is a divisor. 54 is a dividend. Next, we have to divide this divisor value with a remainder. That is, we have to divide 32 by 22. You know that if we take here value as 2, 22 into 2 as 44, that is greater than 32. So we have to take the lesser value, that is here we can take as 1. You know that 22 into 1 as 22. We have to subtract 32 by 22, we get a value as 10. So 10 is a remainder. Next step, we have to divide this divisor value 22 by the remainder 10. Take like this. Here we can take it as 10 into 2 as as 20. So if we subtract 22 by 20, we get a remainder value as 2. Next step, we have to divide this divisor value 10 by the remainder 2. For the take like this, we know that 2 into 5 as 10. 2 into 5 is 10. 10 minus 10, we get a value as 0. We have to stop the division value here because the last remainder is 0. Therefore, we can conclude that the last non-zero remainder for this division is 2. Therefore, we can conclude that the greatest common divisor for this value, that is 32 and 54 value is 2. Also, we have to note that this 2 divides 32 and also this 2 divides 54. Therefore, we can conclude that the GCD of 32 and 54 is 2. Once you obtain the GCD, we have to express it in the form of 32x plus 54y. For that, we have to apply division algorithm method for this value. Here, for this, the division algorithm method says here dividend is 54, divisor is 32 and quotient is 1 and the remainder is 22. So we can take it as dividend which is equal to 32, that is divisor into quotient plus remainder, that is 54 which is equal to 1 into 32 plus 22, or we can take it as 22 which is equal to, take this value to the left hand side, we get as 54 minus 1 into 32. Call this as equation number 1. Similarly, for this value, the division algorithm method applies as divisor into quotient plus remainder, that is 32 which is equal to 22 into 1 plus 10, or we can take 10 which is equal to, take this value to the left hand side, that is 32 minus 22 into 1, and call this as equation number 2. Similarly, for this division algorithm method applies as here 22 which is equal to 10 into 2 plus 2, or we can take it as 2 which is equal to 22 minus 10 into 2. Call this as equation number 3. Next step, you have to take a equation number 3 here, that is last equation you have to take, that is equation 3 as 2 is equal to 22 minus 10 into 2. Next step, we have to apply equation 2, equation 1 and continue the procedure. Here in the place of 10 we can substitute as this value, that is from equation 2, substitute equation 2 value here, that is 2 is equal to 22 minus, here 10 is 32 minus 22 into 1 into 2. Next step, multiply 2 inside the bracket, we get as 22 minus 32 into 2, here minus 2 minus plus 22 into 2 which is equal to, here we have 22 into 1 plus 22 into 2, we get a value as 22 into 3 minus 32 into 2 as it is. Next step, from equation number 1 we can substitute in the place of 22 as 54 minus 1 into 32, that is 22 is 54 minus 1 into 32 into 3 as it is minus 32 into 2. Next step, multiply 3 inside the bracket, we get as 54 into 3 minus 32 into 3 minus 32 into 2. Here we have minus 3 into 32 minus 32 into 2. We can take minus 32 as common, the remaining is 3 plus 2 is 5. Therefore we get 54 into 3 minus 32 into 54 into 3 minus, here in this 2 value we can take 32 as common, that is minus 32 as common, we get as minus 32 into 3 plus 2. 3 plus 2 is 5. Also we have to express it in the form of 32x plus 54y. Here take this value as first value, we can take it as 32 into, here 3 plus 2 is 5, take minus inside the bracket, we get as 32 into minus 5 plus 54 into 3. Therefore, we are expressing in the form of, here this is 2 is equal to 32x plus 54y, where x value is minus 5 and y value is 3. This completes the problem. Here the procedure is same for all the problem, but the different value is the division method. Applying division method is different here. So we have to apply division method carefully here. We shall move on to another problem. Find the GCD of 24 and 138 and express it in the form of 24x plus 138y. Here to find the GCD of 24 and 138, we have to apply division method here. Here take 138 as dividend and 24 as divisor. We have to divide 138 by 24. Here quotient is 5 here. We know that 24 into 5 value is 120. If we take this value as 6, 24 into 6 value is greater than that of 138. That is, we get a value as 148 which is greater than 138. Therefore we have to apply lesser value, that so that we can take this as 24 into 5 as 120. Next step, we have to subtract 138 by 120. We get a remainder value as 18. Next step, we have to divide this divisor value, that is 24, by the remainder 18. That is, we have to divide 24 by 18. We know that 18 into 1 is 18. The remainder value is 6. Next step, we have to divide this divisor value, that is 18 by 6. We know that 6 into 3 is 18. 18 minus 18 is 0. Therefore we get get a remainder value as 0, we have to stop the division method. Therefore, we can conclude that the last non-zero divisor as a greatest common divisor. Therefore, we can conclude GCD is 6 here. Also, we have to note that this 6, that this GCD value divides 24 and also this divides the value 138. Therefore, we can conclude that the GCD of 24 and 138 is 6. This is our finding GCD value. Next, you have to express it in the form of 24x plus 138y. Therefore, we have to apply division algorithm method for this value. Here, for this value, the division algorithm method is dividend, which is equal to divisor into quotient plus remainder, that is 138, which is equal to divisor is 24 into remainder is 5 plus into quotient is 5 plus remainder value is 18, or we can take it as 18, which is equal to 138 minus 24 into 5. Call this as equation number 1. Similarly, for this division algorithm method applies as 24, which is equal to 18 into 1 plus 6, or this is 6, which is equal to, take this value to the left hand side, that becomes 24 minus 1 into 18. Call this as equation number 2. Here this remainder value is 0, so no need to apply division algorithm method for this. Next step, from equation 2 we can take this equation 2 as, that is 6, which is equal to 24 minus 1 into 18. Next step, from equation number 1, here from equation number 1, in the place of 18 we can substitute as 138 minus 24 into 5, that is 6, which is equal to 24 minus 1 into 18 is nothing but 138 minus 24 into 5. Next step, multiply 1 inside the bracket, we get as 24 minus 1 into 138 minus plus 24 into 5. Here we have 24 into 1, here is 24 into 5. You can take 24 as common, the remaining is 1 plus 5 minus 1 into 138, and plus 5 is 6. Therefore, we get as 24 into 6 plus, take this minus sign inside the bracket, we get as 138 into minus 1. Therefore, this is of the form 6, which is equal to 24x plus 138y. So, this is of the form by Euclidean algorithm. G is equal to ax plus by. Here x value is 6 and y value is minus 1. So, we are expressing the value 24 and 138 in the form of 24x plus 138y. This completes the problem. So, these are all some of the problems on finding greatest common divisor. Till here, we studied some of the important problems on finding greatest common divisor. In next video, we study about actual concept modular arithmetic. Hope you all understand the video. Thank you.